Okay, so hello and welcome back to another Python tutorial on sorting algorithms. Now, before I get into this, I just want to say I've recorded two videos today, uploaded them both, then just realized that my microphone was muted, like my OBS recording volume was muted, so I'm gonna have to re-record both of them. But since I've already recorded this video today, I already know what I want to say, so it won't be too bad. Let's get into it anyway. So the insertion sort is probably one of the simplest sorting algorithms. Well, compared to all the other ones anyway. You can write it here. It says you can even write it in 3 lines in C, but we're going to be using about like 6 or 7 lines. It's fine. It's really simple anyway. And the basis on how it works is it takes a value starting at the second value in the list, which is index 1, because the first value doesn't have anything before it to compare to, and it checks the value before it and says, well, is this one bigger or smaller? And if the value before it is bigger, it'll then swap with it, because you want the smaller values to go to the bottom. So as you see, every time it gets a new value, it kind of sinks down till it gets to its right place, and it keeps going down to its right place. And then eventually it'll be a sorted list. And if the value below it is smaller, then it'll stop, because it knows that if the value below it is smaller, then it should stay there, so that eventually the list is sorted. And the efficiency of this algorithm is O(n) squared technically, though some algorithms have a best and a worst case performance, where basically if every character in this list needed to be sorted to the end, then it would be O to the n squared. But if every character was already sorted, then it would be O to the n. Now, I will do a video on big O notation, but think of it this way. If all the characters were sorted already, everything would need 1 check. So if there's 10 bits of data, 10 checks, so O to the n. Whereas if you had to do a check for everything against every other thing, that would be O to the n squared. So every time you had 1, you have to add an extra whole another row of checks. And it'll make sense when I get into the code why that is. But anyway, so I'll link to the Wikipedia page in the description. Let's get into it. Now, some of you have already seen this video. I mean, if you've already seen it, you might not want to rewatch it, unless you want to rewatch it with me speaking. But yeah, I'm going to have to re-upload them anyway. So we need an array of numbers. Now, I'm not going to bore you typing out numbers. I'm just going to copy and paste the ones I used earlier today. So here's the numbers. And we need to write a function for the sort, which will be called Insertion Sort. And it takes in the array numbers. And then down here, we want to call Insertion Sort to do it. And we'll pass in numbers. And then we'll print numbers. Anyway, that's the simple skeleton of it. Now, if we wanted to test this now, just to see whether it's all compiling, it won't, because, well, the function has nothing in it. It even tells you that it's going to compile with errors, and I'm going to do it just for the sake of it. So, you see here, yep, starting, error, whatever. Okay, basically, when we run the function, it's saying, well, there's no code inside the function, and it actually tries to grab this next function, which is actually just calling itself, which is going to cause a bug. The way you can have an empty function just for the sake of, let's say you want to write out all your function names just to have them ready, but you don't want to put anything in them. Normally you might just put, print whatever, and that'll work to hold it. But you can also use something called pass, which is basically just a blank statement. It runs it, counts as part of the function, but it doesn't do anything. It just ignores it. So now, yep, starts, and it prints the list, but it's not sorted yet because we haven't done the algorithm. So your goal now is to pause and write the algorithm inside here. And what we need to do is, the things you need to take into account is, we need to loop so that the check happens for every character in the list starting on the second character, which is index 1. So that's one thing you need to take into account. And then you need to compare every value to the one before it. And if the one before it is bigger, then you want to swap with it. But you want to keep going until the character below it isn't any bigger. And then if you get to the end, you want it to stop as well, because if you're at the smallest, then you're at the smallest, and that's basically how it works. Obviously, you can write this in you can write this in 9 lines inside of the function. You can probably write it in less. I might not have the most shortest lined way of doing it in Python, at least. But if I can write this whole thing in 17 lines whilst having white space gaps, it's pretty efficient. So let's get into it. If you want to have a go at it, pause, go and have a go. But if you're here now and you want to know how to do it, let's get into it. So, as always, I want to make a loop. So for I in range, then what's the range? Well, we don't want to start at 0 like normal. We want to start at 1, because there isn't actually a point in comparing the first one. You can actually start at 0 because the while loop that I'm going to write kind of takes it into consideration, but just starting at 1 makes more sense because there's never going to be a value below index 0. You can't have index -1, so we'll start at 1, and we're going to go to the length of the numbers because we want to do a check on the last value of the list as well, on all the ones before it. We will see, and if you're ever worried about writing len numbers and you don't know whether it should be len numbers or len numbers -1, just try it if you don't know, because you'll get an error message of out of range exception error, because if that happens then you know you need to have the -1, or maybe something else is wrong. But if you run it and it's absolutely fine, then you should know that there's no problem with that. Then we need some kind of temporary variable, so temp, and that's going to be equal to the number we're currently checking. So the first index we check is 1. So temp is going to be the number we're currently checking, which is 81. So we're going to store 81. And then we also need to know what position we're currently checking. So position can be equal to I, which is the index of the character we're currently checking. So let's say we're checking 81. The position would be 1. And 72, the position would be 0, 1, 2. Now that we've got these variables, we can now do stuff with them. So we need to write a while loop. So while position is greater than 0. Now what this does is, if we're going to be checking down the list and we're going to keep going down, 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 if we're currently checking the position 0, well, we don't want to check the position 0. We only want to check the ones that are greater than position 0. So this while loop is only going to be true while we're not as low as position 0. Because if we are, there's nothing below it to check to. So this stops us having problems with checking below the bottom of the list. And then we also want to say, and we also want to check that numbers position -1 is greater than temp. Now what that is doing is we're checking, is the number before the one we're currently checking. So let's say we're checking a 72 against 81. Well, if the one below it, which is position -1, if the value in the list below it is bigger, then we'll run it because we want to move it down if it's bigger. But if this one below it was already small, then we wouldn't do the check. So these are the two things we need to check before running the while loop. And then inside the loop we want to say, well, numbers position is equal to numbers position -1, which basically lets us move down the list with our number until it gets to the right place. And every time we do this, we also want to reduce position by 1, so that we know that we're checking down the array. So obviously if we start here and it's 2, then we go to here, we need to change this down to 1, so that we know we're currently checking 0, 1, which is this one. And then, because obviously if position goes down, then this position and position -1 will go down as well. So we, instead of comparing these two, we'll compare these two and so on. And then outside of the while loop, we'll say, well, numbers position equals temp. So by the time, when we eventually get to the one that isn't any bigger, we just say, well, now we're ready to set the current position to the variable that we're at. So obviously if this didn't get ran, if we started here and we say, well, temp is 72 and position is 2, and we get to the end, all we're doing is just doing the same thing. We're saying, well, numbers 2 is the temp, which is 72. So if there's nothing, if it doesn't get moved, it'll just reset the same value. Whereas if it does get moved, then it's going to set it. But anyway, that's it actually. It's a very quick video. Obviously I probably did it quicker this time because I've already done it today once. If we run it just to prove it works, 2, 23, 58, yep, so on, so on, so on, it works. Hopefully it makes sense to you. It's not that complicated. I'm actually going to zoom in for the people who want to read the code on their phones or whatever. For some reason people decide they want to do that. So obviously we get our array, our function here, and then this is where we run it and print the result. And then inside it, we're looping for each character. We're getting a temporary. I mean, obviously, as I said, you can get it down to like just a few lines if you want to really bring down the loop from line 3 to line 10. So that's 7 lines. But if you not include this, it's actually 6 lines. So you can probably even get it less than 6 lines, to be honest. But that's still very efficient. Having extra white space doesn't really make a difference anyway. But it's a lot nicer and probably better just to have it more readable than having some extra white lines. And as far as I know, when you compile the code, it ignores the white lines anyway, so it doesn't really matter. So yeah, if you like this video, then obviously just like the video, subscribing would help. I'm going to make more Python tutorials as well as shader tutorials. After this video, I'm going to re-record my Fire shader graph video that I don't think many people got to actually see because it was only up for like a few minutes before someone told me that it had no audio because I was an idiot and I forgot to unmute my microphone. But hey, anyway, yeah. So I'm gonna link the insertion sort thing if you want to have a read about it. And as I said, I'll do a video on big O notation soon. But anyway, so yeah, if you like the video, then do what I said, please. And if you enjoyed the video, yeah, thanks for watching and goodbye.